Good morning, everyone. We'll get started here in about another minute. Thank you and good morning. My name is John Moore, and I'm the media contact for today's Hurricane Outlook Midseason Update. Before we get started, I would like to go over a few housekeeping items with you. This webinar is being recorded, so if you do not wish to be recorded, please disconnect at this time. Today, you will hear from Matthew Rosenkrantz, lead seasonal hurricane forecaster at NOAA's Climate Prediction Center, who will deliver NOAA's updated 2023 Atlantic Hurricane Season Outlook. Mr. Rosenkrantz and his team update the seasonal hurricane outlook initially issued in May each year in early August as the peak months of the season get underway. You will be able to find a news release and graphics related to today's release posted to NOAA.gov momentarily and through the link that will be provided via chat later on in this broadcast. Also later in the webinar, following Mr. Rosenkrantz's remarks, you will have an opportunity to ask questions about the outlook. Should you have any additional questions about the outlook or would like to schedule a follow-up interview with Mr. Rosenkrantz, please contact me at john.moore@noaa.gov. That's john.moore@noaa.gov or by phone at 202-603-2523. And with that, I would like to turn it over to Matt to deliver the updated outlook.
Thank you, John, and thank you everyone for joining us for today's announcement. The Atlantic hurricane season officially extends from the 1st of June through the end of November. So far this season, there have been 5 named storms, including 1 hurricane in the Atlantic Basin. We are now entering the peak months of the Atlantic hurricane season, August through October. Historically, this is when about 90% of all tropical storm activity occurs in the Atlantic, which is why we issue an updated outlook in early August. And now, on to the updated 2023 outlook. Atmospheric and oceanic conditions now slightly favor an above normal 2023 Atlantic hurricane season. We have increased the chances for above normal activity to 60% from 30%. The likelihood of near normal activity has now decreased to 25% from 40%. The chances of a below normal season are now at 15%. We are now predicting the likely ranges of tropical storm and hurricane activity to be 14 to 21 named storms, of which 6 to 11 could become hurricanes, and 2 to 5 of those could become major hurricanes. Major hurricanes are hurricanes that reach category 3, 4, or 5 with winds of 111 miles per hour or greater. These ranges take into account the 5 named storms, including 1 hurricane, that already formed this season. Please keep in mind that NOAA's hurricane season outlook is a general guide to the overall seasonal activity and does not predict landfalling storms. Landfalls are currently only predictable within about 1 week of a storm potentially reaching a coastline. In making this outlook, there are several climate factors we analyzed that contributed to our prediction of an above average hurricane season. The main climate factors expected to influence the 2023 Atlantic hurricane activity are the ongoing El Nino and the warm phase of the Atlantic multi-decadal oscillation, which includes record warm Atlantic sea surface temperatures. More specifically, odds are in excess of 95% that the ongoing El Nino will continue through the autumn of 2023. Typically, El Nino-related changes to the atmosphere inhibit tropical activity in the Atlantic, especially in the Western Caribbean and the Gulf of Mexico. This year, the changes typically associated with El Nino appear to be emerging a bit later than initially anticipated, so the season could have more activity than foreseen in the May outlook. If those El Nino related changes move in quickly, activity could be near the lower end of our ranges. If the local conditions in the Atlantic prevail for longer than anticipated, activity could be near the upper end of our predicted ranges. One of the local conditions in the Atlantic that we monitor is the sea surface temperature. The June-July sea surface temperature in the main development region of the North Atlantic were the warmest since 1950 at 1.23 degrees centigrade above normal. Warm waters are conducive to more development, and those warm waters likely contributed to the development of 2 tropical storms in the deep tropics during June. Tropical storm development in the deep tropics during June and July is usually a harbinger of a busy season to follow. We also monitor and predict the West African monsoon, as a stronger West African monsoon is typically related to more tropical Atlantic activity. During 2023, the West African monsoon rains have been robust, but the related wind patterns have been nearer to normal, giving a bit of a mixed signal into the outlook. The ongoing El Nino, potentially competing with local conditions in the Atlantic, increase the uncertainty in the outlook. The increased uncertainty relative to years when climate factors such as El Nino and the sea surface temperatures in the Atlantic align or reinforce each other is reflected in the relatively lower probabilities and slightly wider ranges. No matter the overall activity, we urge you to prepare now for the upcoming core of the hurricane season, as a single storm can have catastrophic impacts. FEMA's ready.gov and your local emergency management office are key resources to helping you prepare. Preparing now makes for a safer and more resilient community should a storm strike your area. Additionally, in recent years, we've seen the threats from hurricanes expand beyond damaging winds and dangerous storm surge to torrential rain and inland flooding, threatening life and property far from the landfall location. If you are in a region prone to inland flooding, stay tuned to the National Hurricane Center and your local weather forecast office for the latest watches and warnings. Also, be sure to adhere to advice from your local emergency managers during a storm for evacuation and safety information. And now I'll be happy to take questions about the outlook.
Yes, thank you, Matt. Thanks for those remarks. At this time, Matt will take questions about NOAA's 2023 mid-season hurricane outlook update. If you have any questions that are not related to the outlook, please reach out to me following the call. To ask verbal questions, please use the raise hand feature. You can also submit text questions through the question box. We will start by taking a few verbal questions before we begin to alternate until our time is up. So wait until we call you, and once we call on your name, please unmute yourself, then state your affiliation and ask your question. All right, first off, we have Seth Bornstein with the AP. Seth, I'll unmute you. Please unmute yourself as well.
Thank you. I assume you can hear me. Thanks for doing a Seth Bornstein AP. In 2 questions, Matthew. First, just when I looked, at the Hurricane Center archive, it's got Hurricane A through D and Dawn, and that's 4 of them. So can you explain why there are 5 named storms, but we only go through Dawn, which is, 4th? And second, more importantly, in terms of how this compares to your May forecast, is it fair to say that the Atlantic sea surface temperatures are worse? Not only are they warmer than ever, but are they warmer than you thought? And in other words, this battle that we talked about 2 months ago between El Nino and sea surface temperature for control of the hurricane season, is it fair to say the sea surface temperatures are winning? the hot Atlantic is winning versus El Nino. We can't hear you.
So you mentioned the 4 named storms that we had. Oh, can't hear me?
Yes. Yes.
So if you can hear me, the
Yes.
4 named storms that we mentioned, with the names A through D, there was a unnamed subtropical storm in January, and the name in the record is officially unnamed. So that's its name. So there have been 5 storms this calendar year. As far as the rest of it, yeah, a lot of the predictions from May did not forecast a continuation of record warm sea surface temperatures. It's very rare for most models to forecast continuations of records, but the observations have come in where we continued those record conditions in the Atlantic. So they are slightly warmer than what we had initially anticipated in May. As far as winning, I don't really describe it as winning or losing. It's just that the impacts of El Nino have been slower to emerge over the Atlantic, whether that's directly related to just the sea surface temperatures and local Atlantic circulation, or are the El Nino related changes that we typically see around the globe being impacted and ameliorated through other mechanisms, something in Asia, some mid-latitude circulation. And we wouldn't be able to say that until kind of the end of the season when we did an attribution and modeling study.
And when you're saying impacts, I just want to be clear. Are you talking about the wind shear is what we're not seeing mostly?
Wind shear and changes to the vertical stability and moisture profiles in the Atlantic. Those are the 2 main impacts from El Nino.
Thank you.
All right, thank you, Steph. Next, we'll go to Roshan Higgins. Roshan, you can unmute yourself and ask your question.
Yes. I just wanted to ask if you all are considering warm temperatures in the Gulf of Mexico and like the loop current, and if that's gonna affect how strong hurricanes or tropical storms are gonna be.
So specifically, none of the forecast tools take into specific account the sea surface temperatures of just the Gulf of Mexico. They are looking at sea surface temperatures in the tropical Atlantic and the main development region, which includes part of the Gulf of Mexico. And the loop current, that evolves with warm and cold patterns on time periods of weeks. So that'll go through a warm and a cold phase, shedding off warm or cold gyres a few times throughout the core months of the hurricane season. And it typically has more of an impact on individual storms, or if a couple of storms move through that region when there's a warm eddy or a cool eddy. So we don't explicitly predict the loop current on a seasonal timescale.
Okay.
Thank you for your question, Rashawn. Next, we'll go to our question box. Our first question is from Chase Kane with NBC Universal. Matt, Chase wants to know, how might the extremely warm sea surface temperatures impact both rapid intensification of storms as well as their range? Do we worry about storms impacting further north along the East Coast?
So during active years, there is a doubling of the chance of a hurricane making landfall on the East Coast of the US relative to normal or inactive years. The warmer waters and rapid intensification, the rapid intensification is really a short-term phenomena. It happens by definition with 24 millibars within 24 hours. There's formal definitions for rapid intensification, whether you're talking about winds or pressures. And those short-term fluctuations are best addressed with the National Hurricane Center products and the team there that focuses on short-term variations in tropical cyclone and hurricane activity.
All right, thank you, Matt. Next, we'll go to Chad Merrill on the line. Chad, please state your affiliation before you ask your question. I am unmuting you now.
Hello. Yes, I am with the ABC affiliate in Southern West Virginia, WOAY TV. I'm the chief meteorologist there. And my two questions were, first, when do you expect the Saharan dust to likely dissipate? I know the Saharan dust has been a factor in inhibiting tropical development. And the storm that was off the coast Memorial Day weekend, I know that there was some indication there was an eye with that particular storm. Is that one that you will diagnose after the season to see if potentially it was a subtropical storm?
So Saharan air outbreaks typically peak in the month of July. So we should start to see them wane. We saw a lot of this last year where there was very little activity in July and even the first part of August, most of August. We ended up with 14 named storms and 8 hurricanes in the second half of the hurricane season. And when you look back through data, going back to the mid 90s, so 20, 30 years of data, Saharan air outbreaks do peak in early July, and then they typically will fade off in both their intensity and frequency as the season goes on. National Hurricane Center, as far as the second part of your question, the National Hurricane Center does review last year's or the activity during the past year. So they may determine that there was another unnamed subtropical storm out there if it had an eye, but it would depend on many criteria such as the wind profiles around the storm. Was it in many of the quadrants of the storm, and all the things that would define it as having tropical characteristics or not. And as far as those characteristics, the staff at the National Hurricane Center determines the naming, unnamed, or not naming of a storm or a system during the review process. So they'd be the best answer to the question as far as, are they going to go back and look at that specific storm?
Okay, and that probably wouldn't be diagnosed until the end of the season, correct?
Yeah, so at the end of every season, they do go back and analyze every storm that was named and potentially other storms that were not named but are of record to create the best tracks data, or the HERDAT file that we use that are considered the official record for tropical storm activity in Atlantic.
Okay, thank you very much. Appreciate it.
Sure.
Thank you. Next, we'll have a text question from Mary Roloff with Forbes. How does this season's outlook compare to recent years?
I'm not sure exactly what's meant by that, but this season's outlook now, the updated outlook for 14 to 21 named storms would put us in line with last year's outlook, where we had 14 named storms, or last year's observations where we had 14 named storms. 2021 had 21 named storms, and 2020 had 30 named storms. So we've seen some pretty busy years recently. Our 6 to 11 hurricanes that are forecast this year, which we had 5 to 9 forecast earlier, would be in line with the 8 hurricanes we had last year and the 7 hurricanes from the year before that. Normal for each one of these categories is 14 named storms, 7 hurricanes, and 3 major hurricanes.
All right, thank you. Next, we'll go to another question, text question. This one from Nicholas Spangler with Newsday. Nicholas wants to know, can you talk a bit more about the potential impact to the Long Island, New York, and any change to Long Island and New York City, and any changes from the May forecast for that area?
There are no specific changes to this outlook related to Long Island or the New York City area, because these forecasts are for the overall Atlantic Ocean, including the Gulf of Mexico and the Caribbean, and activity for those. As far as regionalizing these outlooks, it's something we're researching and looking into, running numbers and statistics, and when we can confidently make outlooks for sub-regions, parts of the basin, the Atlantic Basin, such as things closer to the coast, we'll start releasing them. But we're working on the statistics for them because you really want to make sure that those are very solid statistics before releasing them to the public.
All right. Thank you. Our next question comes from Anthony Wood from the Inquirer. And Anthony wants to know, NOAA researchers and others have found that cleaner air may be a contributor to the Atlantic sea surface temperatures. Is it possible to distill that effect from AGW or anthropogenic global warming? What are the best estimates of how much AGW is contributing to an enhanced rainfall and storm intensity?
Sure. So disentangling the aerosols from the anthropogenic global warming, that's still ongoing research as far as which one has a more prominent impact in the Atlantic. Being that the aerosol study was released a year or two ago, and then fully, just decoupling those two mechanisms, right? Because cleaning up the air from the aerosol particulates was kind of a response to some of the pollution noted that also drives global warming, so they're very intimately tied. The latest estimates are that by 2100, the AGW and climate change could impact up to about 7% higher in rainfall. We're seeing about 2 to 3% of that right now from the higher end of the highest rainfalls in some of the storms. We're seeing about 2% higher in the winds as well. If you take out all the other factors and run simulations of the storms with and without the anthropogenic warming.
All right, thank you. Our next question is from Judson Jones of the New York Times. Beyond the 60%, how would you describe your confidence in the forecast for the season?
So these outlooks are all given with what we call a 70% confidence range. That means for all these outlooks that we put out, 70% of the time, the actual number of storms and hurricanes and major hurricanes and activity will fall directly within our predicted ranges. 15% of the time it should be below, and 15% of the time it would be above our predicted ranges for a total of 100%. So we calibrate all of our outlooks and our model outlooks to give us a range of outlooks that will encompass 70% of the historic, those tools over the historical time when we create the statistics behind all these tools. So our confidence now, it's higher than it was in May because we're closer to the season, right? So that's why we have slightly higher probability for some of these categories. But overall, these entire outlooks and everything are given with a 70% confidence range.
All right, thank you, Matt. Our next question comes from Catherine Vaughan from Axios. Just a follow-up question about the Gulf of Mexico. Can you describe roughly which part of the Gulf is part of the main development region?
So it would be the southeast portion of the Gulf. The main development region runs from about 9 degrees north up to 20 or 21 degrees north latitude, and then runs west all the way to 80 degrees west, so basically the coast of Central America. So it'd only be the very small southeastern portion of the Gulf of Mexico that's in the main development region.
Thanks. Our next question comes from Michelle Ma of Bloomberg. What would you say is the biggest change in this outlook compared to May?
The biggest single change is that we've increased the odds for an above normal hurricane season overall, upping our ranges a little bit. And that's really to account for the prior activity and the continued record warm sea surface temperatures in the Atlantic.
Thank you again, Matt. Our next question comes from Shira Moulton of the Sun Sentinel. She wants to know, do you have any sense of when El Nino's impact might begin to emerge, and if these effects would be after the peak of hurricane season?
So right now, some of the models we look at show some of those impacts really starting to emerge in September. We're seeing some changes in the wind patterns over the Pacific that we hadn't really seen and during June. We saw some of those emerge during July and the early parts of August. So if they're starting to consolidate over the Pacific, 30 days or so after that, you'll start to see them emerge in more remote locations from the Pacific, where El Nino changes the circulations and wind patterns around the entire planet. It's not instantaneous, so it kind of spreads out from the central Pacific, moving around the planet in a few different ways.
Thank you. Our next question comes from Janet Babin. Janet wants to know, how typical is it for revisions to happen to the season probability? So is the 30% increase in above normal atypical? Is the 30% increase in above normal season atypical?
I mean, we revise the forecast every year. The ranges that we have forecast this year, the changes in those ranges are not record changes. They're not the largest changes we've ever made on the past. The changes in named storms is only the 5th largest change. We've been doing this outlook about 20 years, so 5 of them have been larger changes. We've had a few changes, revisions in the ACE, the total ACE for the season, that were larger. 2005, 2020 stand out above it. So these changes are well in line with many of the prior outlooks that we've made.
Thank you. Our next question comes from Victor Rodriguez of Amazon. Are there any standout anomalies in the model analysis? For example, heavier flood risks or signals indicating unusual activity?
Signals in the models, one of the biggest changes that we saw was the forecast wind shear over the Atlantic is forecast by many of the models to be lower than it was, which lower wind shear is conducive to more tropical cyclone or tropical storm formation. So now most of the models are forecasting either near or below average wind shear, when in May, some of the models had forecast the above average wind shear, which was consistent with an El Nino forecast back in May and those impacts coming in. But we're seeing a little bit less of that wind shear than we thought we would have to this time. So it makes sense with what the models are forecasting as well.
Thank you. Our next question is from Kimberly Miller of the PV Post. You mentioned the West African monsoon and how the rains have been robust, but I missed what was happening with the winds. Have there been fewer tropical waves coming off the coast?
So the rains in Western Africa during June were about the 90th percentile from the historical observations, which we have pretty good observations of that going back at least to the early 80s. So those rains were robust. The wind patterns that we look at are low level flow, about 5,000 feet off the ground from the Atlantic Ocean into Western Africa. A lot of those winds were near normal. And then the outflow at the top of the monsoon up at about 40,000 feet. Those winds were not only near normal in activity or in strength, but the direction of those winds was not really supportive of reinforcing the monsoon. So there have been some local features in the monsoon that maybe could have created some of those heavier rains. But when we look at month-long averages and real top of the atmosphere and bulk measures of it, they did not reflect in those statistics that well. We have seen a couple of stronger waves come off of Africa. The African waves typically peak in late August and into September, so that we haven't seen that many waves come off. Not that surprising. Some have moved west off the west coast of Africa and been impacted by the drier air in the Saharan air layer that is there. But 2 of them were able to form into tropical storms earlier this year. So, and those 2 storms that formed in the deep tropics have their origins as waves moving off of Africa.
Thank you. We have a few more questions to go. The next one is from Kat Clifford from NBC Universal. Without the record warming ocean, what is the usual impact of El Nino on the hurricane season?
Without the record sea surface temperatures, the typical impact of El Nino on the Atlantic hurricane season would be a season that only had about 9 named storms and only about 4 hurricanes and 2 major hurricanes. So when I run the analysis in past years, just sorting out El Nino years, you get a reduced activity. So if we were to just have a normal El Nino year from now on out, normal would have been about 2 named storms a normal year during any year, El Nino or not. But we've already had 5. If we have the rest of a normal El Nino year of 9, that means maybe they already had 2. That would imply that we have at least 7 more to go. And we've had 5 already, so that would put 12 total for us. If I consider nothing else but El Nino. Then the record warm sea surface temperatures, the models predicting the reduced shear, has added a couple of those storms as we went on in making this outlook.
Thank you, Matt. Our next question is about one of the new tools that NOAA developed and deployed this year. So it's from Rose Snable. Did the new hurricane analysis and forecast systems known as HAFS, which was implemented in June, influence the confidence of these predictions?
No, the HAFS is used more for individual storms, storm tracks, and shorter term forecasts. It's not really set up to do seasonal and longer scale forecasts.
Thank you.
Mm-hmm.
We're going to go back to a question about record warm sea surface temperatures. This time it's from Alex Harris with the Miami Herald. Can you put into context for us how unusual this season is with record warm sea surface temperatures and potentially a historic strong El Nino happening simultaneously?
But almost by definition that we have record warm sea surface temperatures, there are no analogs. So putting it in context is by saying that it's record. And that record that I use goes back to 1950. I haven't done an analysis that goes further back than that because I don't have the corresponding hurricane data that's reliable as well. So I tend not 1950 is about when we started doing most of this more recent hurricane analysis periods. When I do look at analogs years in past that we have warm sea surface temperatures in the Atlantic and an El Nino during the hurricane season, I only really found one pretty good analog, and that was 2004. There's some analogs in the late 1950s and early 60s that also showed the warm sea surface temperature in the Atlantic and El Nino activity, but they were not on par with the magnitude of this event.
All right. Thank you again, Matt. This time we'll switch it up and go to a hand raise for a verbal question from Seth Bordenstein with the AP. I'm unmuting you. Well, you can unmute yourself, Seth.
Thank you. A couple very quick questions. You referred to your ACE forecast, but I don't see what number ACE you've or what percentage ACE you've used, and it's not in the press release. What is the forecast for the ACE, and what is that percentage compared to normal? Also, in terms of the main development region, is it fair to say it stretches all? You gave the good north-south. Is it fair to say it stretches from Central America all the way to Africa? And finally, is it fair to say that what we've seen now, the 2 named storms that already, that normally it's 2 named storms and we've had 5 already by this point, is that considered above normal or very much above normal? I know you guys have that gradation. Thank you.
Sure. So the ACE forecast for this upcoming season has also been revised upwards to 105 to 200% of normal. And normal is our median statistic. We use median for our normal statistic.
Okay.
The second question you had?
does the MDR stretch all the way to Africa?
The MDR is formally defined as 20 degrees west longitude to 80 degrees west longitude and 10 degrees north to 20 degrees north. That's formal definitions. A lot of the detailed analysis we do happens on grid points. So you'll take into account 1 or 2 grid points north and south of that. So often the analyses go from about 9 degrees latitude to 21.5 degrees latitude.
Okay, perfect. And the official characterization of activity up till now, is that considered above normal or very, high, I know you don't use way, there's another word you use.
Much above normal.
Much above
We're
normal, yeah.
hyperactive. Those
Yeah.
decisions are made at the end of the season. We don't really clarify, with such granularity during the season. To date, activity in the Atlantic has been above normal.
Okay. Thank you.
Yes, sir.
Thank you, Seth. We'll go back to text questions now. We have a question from Sam Walker from WOVX. With higher sea surface temperatures in the Atlantic, is there any data to suggest that tropical activity could increase outside of the current season window?
Warmer sea surface temperatures in the Atlantic and the typically associated wind patterns with those warmer sea surface temperatures do normally favor a bit of broadening of the season into the June and July time period and potentially into the November period. Should these warmer waters hold on into later in the season or November, it would be more conducive to having a late season storm. This year, though, we have the ongoing El Nino, and El Nino's impacts tend to ramp up as the longer the event goes. So we should start to have some very strong impacts from El Nino later in the season. Although that kind of pulling of these two factors is really the root of most of the uncertainty we have in this outlook. And the forecast team we've analyzed numbers, debated the results of those analysis for hours in making this outlook.
Thank you again, Matt. We have a new question from Daniela Hernandez from the Wall Street Journal.
Sure.
Why can't hurricanes only be predicted 1 week out? What are the data limiting factors? What are the limiting factors that prevent hurricanes from being predicted in depth 1 week out?
So I think the question was referring to hurricane landfalls, which are best predicted 1 week out. You can predict hurricane landfalls at any time period, just that they would be wildly inaccurate if you do them at further out periods. We already know the Hurricane Center has made tremendous improvements in forecasting the tracks of hurricanes over the last 20, 30 years. Track errors now at 5 days are on par with where they were 2 days in the past, 25, 30 years ago. So they made tremendous advancements. But if I were to do hurricane track forecasts 90 days from now, they would have large errors, so large that they would not be useful. And then when you sum them up to make landfall predictions, you can have very large errors in those. So we're researching ways to do it and ways that when we put out information are useful to people who could use that information. So, and you asked a question on a limiting factor in that. Some of the limiting factors are observations, the forecast state of El Nino, and then the impact of the wind shear. That's not certain all the time. So the better observations we would have of El Nino to change those wind shear profiles and change the wind patterns around the globe could lead to better forecasts for landfalls. Even within some of the climate models that we use, as advanced as they are, there are errors in them. We correct them, we bias correct them, we do all kinds of things for those. The team here at NOAA is always working on ways to improve those models. But again, they're models and they're estimates of what we think the future is going to be. So with those errors, they would be very large at forecast lengths of 40, 50, 60 days out into the future. So we'd want to make sure that those numbers are both relevant, useful, and as accurate as they can be.
All right, thank you, Matt. We have only a few more questions here. Our next question is from Amy Green with Inside Climate News. Amy wants to know, which is the more important factor in this updated outlook? Was the delayed El Nino impact the most important factor, or the Atlantic sea surface temperatures? Or were both factors equally important? How would you characterize that?
Both factors were equally important. When you look at historically, each one of those factors can be responsible for between 30 and 40% of your tropical cyclone variability in the Atlantic. So they're kind of both on equal footing when we do the analysis.
All right. One question from Catherine Bourne from Axios. When you say that these are the warmest sea surface temps since 1950, I just want to make sure, since 1950 is how long your analysis goes back, right? 1950 didn't have warmer sea surface temperatures?
Correct. The analysis that I run starts in 1950. Every year between 1950 and now was cooler than the temperatures now.
Okay. And our second part to our question, can you talk a little bit more about 2004? How did sea surface temps and El Nino conditions compare to this year?
I'd have to get back to you on the details of that. I do have an extensive set of graphics. I just don't have those graphics memorized to be able to talk about 2004 specifically. I do know 2004 ended up with 15 tropical storms, 9 hurricanes, and 6 major hurricanes, and ACE value of 200% of normal, about 200% of normal.
All right. We have one final question from Rami Abukalam with the Wall Street Journal. It sounds pretty concerning. How worried did you get when reading this data, and how worried should people be about this forecast?
I don't think people should worry about the forecast. I think people should worry about and prepare for the storms that this forecast implies. So going to ready.gov or your local emergency management website and reading the tips there, and getting your family, if you own a business, getting the business prepared for the upcoming season. Because it doesn't just take one storm coming through your area. The west coast of Florida found that out last year during a relatively quiet year. There was devastating impacts. So preparing now, preparing early, understanding where you're going to go, what your family's going to do. Should an evacuation notice be ordered? Even if an evacuation notice is not ordered, where would you want to go? What would you want to do? How would you want to prepare for an upcoming storm? Thinking those things through now, getting some supplies now is much easier than when there's a rush on supplies in the last couple of days. When you're under the crunch for the time crunch to make decisions and prepare things, having those plans at least thought through, maybe even written down, maybe even practiced with your family, especially if you have, a son or daughter off at college, and they've got to then make the transit to home, and then you've got to make the transit to evacuate somewhere. Designing a plan that maybe just meet up somewhere else on the way. Thinking those things through can really help save some time should a storm impact your area later.
All right, I'm going to give it one final check for questions. I'm not seeing any more. I'm not seeing any more hands raised. So with that, we're not seeing any further questions. So this will conclude our briefing for today. You can find the news release and the related graphics from today's call on NOAA.gov. This call will also be recorded and posted on NOAA.gov later today, so you'll have access to it. If there are any additional questions, please contact me by email at john.moore@noaa.gov. Again, that's john.moore@noaa.gov, or by phone at 202-603-2523. Thank you again for joining us today. You may disconnect at this time.